Welcome to the Tech Life Well podcast with Theo Hale and Aria Wells. Thanks for joining us.
Right.
Today we are looking squarely at a massive shift happening right on top of your desk.
Yeah, the rapid, almost aggressive rise of AI mini PCs.
Exactly. For the longest time, if you wanted to do anything serious with artificial intelligence, you were sending that request off to a massive cloud data center.
Right.
But now we are moving away from needing those massive servers. That power is coming directly to the desktop in this really tiny form factor.
It really is a significant pivot. I mean, we aren't just shrinking a computer. We're looking at a fundamental change in the architecture.
Right.
It's a whole wave of hardware innovation, specifically new chips from Intel and AMD and Qualcomm that let you run complex AI models completely locally.
Which gives you better privacy.
Exactly. Privacy and wellness-focused productivity. You're honestly reclaiming control from the cloud.
So we're going to explain exactly what makes these machines different from that old clunky desktop tower you used to have.
And we'll cover the major players fighting for your desk space and the software making it all work.
So let's just start with the fundamental question. Why do you need a specific quote-unquote AI computer?
Right. Why not just use the normal PC you already have?
Yeah, exactly. Why can't my current machine do this?
Well, it's really the convergence of three distinct forces trending right now in this 2025 to 2026 timeline.
Okay.
First, modern chips actually have a dedicated component now, the NPU. Second, the operating systems like Windows with Copilot Plus are actually mandating on-device AI requirements.
So they are forcing the hardware to catch up.
Basically, yes. And third, we have this explosion of open source tools like llama.cpp that let regular people run large language models without a server farm.
Let's back up to the NPU thing. What exactly is that? I know the CPU is the brain and the GPU handles graphics.
Right, so to understand the neural processing unit, you have to look at how processors handle math. Think of the CPU as the manager of the office.
Manager, okay.
It's versatile. It answers emails, directs traffic, keeps things from crashing.
Yeah.
And the GPU is the heavy lifter.
The muscle.
Exactly. It has huge raw power for parallel compute, but it's expensive to feed. It needs massive amounts of energy.
So it drains the battery.
Fast. If you use your GPU for a background AI task, your fans spin up and your battery dies. Enter the NPU. It's the highly efficient specialist.
So it just handles specific math.
Matrix multiplication specifically. It isn't stronger than the GPU in a raw burst, but it is incredibly efficient for sustained operations.
Which brings up that metric everyone uses now, TOPS.
Trillions of operations per second.
Right. Microsoft is drawing a hard line there.
They are. Their Copilot Plus guidance requires a baseline of 40 plus TOPS for the new Windows AI features.
But wait, a massive graphics card has way more than 40 TOPS, right?
It does, but again, the GPU is a sprinter. The NPU is a marathon runner. It provides sustained performance per watt so you can run always-on features like noise suppression without hogging your GPU.
Okay, that makes total sense. Yeah, it's about efficiency. So let's talk about the physical boxes.
The mini PCs.
Yeah, they look like those tiny, sluggish boxes IT departments strapped to the back of monitors.
But they're completely redesigned. They're tiny, like 0.3 to 1.5 liters. I call them local AI factory.
Local AI factories, I like that. So who is making the best ones?
It's a battle of the titans. Let's start with Intel and their Core Ultra Series 2 chips.
Like the Asus AI NUC and the MSI QB NUC AI.
Exactly. Those use a 3 AI engine architecture balancing the CPU, GPU, and NPU. They are laser focused on AI for work.
I know the MSI QB also pushes the sustainable design with recycled plastics and dual LAN ports.
It does, and the Asus ENUC 14 Pro AI is really the enterprise standard. It actually features a dedicated Copilot Plus button and fingerprint security.
Okay, so what about AMD? Their Ryzen AI processors. Strix Point, I think it's called?
Right, Strix Point, that's the performance leader. The AMD Ryzen AI 9 HX 370 processor is phenomenal.
Which is in the Minisforum AI X1 Pro.
Yes, the enthusiast community calls that one the Mac Mini Killer. It hits 50 NPU TOPS.
So it easily clears Microsoft's requirement.
It does, but it also has an Oculink port, which is a huge deal.
Oculink, what does that let you do?
It allows you to connect an external desktop GPU later on, like an RTX 5090.
So you aren't stuck with the graphics it comes with, you can upgrade later.
Exactly. Now AMD is also in the Sapphire Edge AI 370.
Which is more for creatives, right?
Yeah, great for Premiere Pro and
Yeah.
Photoshop. But the reviews note the fans get quite noisy under load and it struggles with heavy gaming unless you have a discrete card.
Makes sense. Now let's touch on the Beeling GPR9 Pro,
The heavyweight, it uses the Strix Halo chipset.
which gets you up to like 80 NPU TOPS.
Massive power. But the coolest feature is a built-in 4 microarray.
Specifically for voice dictation to local LLMs. You just talk to the room and it listens.
Exactly. It's shifting how we interact with the machine entirely.
Now there's one wild card out there, the Orange Pi AI Studio Pro.
The outlier, yes. It uses a Huawei Ascend 310 AI chip.
And the stats on it are confusing. It claims 352 TOPS, which sounds enormous.
It does, but it's ARM-based and runs Ubuntu Linux.
So the software support is going to be really tricky compared to x86.
Very tricky. Plus, it has extremely limited ports, like a single USB-C for everything. It is strictly for developers, not average users.
Good to know. So skip the Orange Pi if you want an easy life. Let's talk about software. You buy the box. How do you actually run the AI?
The universal translator of local AI is llama.cpp.
Which allows you to run models on almost any hardware, right?
We're pressing them from 32-bit floating points to 8-bit or 16-bit.
Exactly. So they actually fit into the memory of these small devices.
And Microsoft is simplifying this whole process too.
Yes. With Windows ML and the ONNX runtime, it acts as a traffic controller.
So developers just use ONNX, and Windows automatically picks the best chip for the job. Right. And Qualcomm has their QNN execution provider to optimize specifically for Snapdragon NPUs.
And Intel has OpenVINO to accelerate AI on Intel hardware.
It all works together to make running models locally seamless.
So what are the practical use cases? What does a user actually do with this?
Privacy is the biggest one. Running a local chatbot like Llama 3 or Mistral means your data never leaves the house.
Your prompts aren't sitting on a server somewhere.
Never. The second use case is agentic AI, productivity.
Meaning the PC acts as a background agent.
Right, it doesn't just answer questions, it organizes files or drafts emails in the background without draining your system.
And creative work too, like AI upscaling for video editing.
Huge time saver. But there are limitations we have to talk about, the gotchas.
Right, what are the downsides of squeezing this much power into a tiny box?
Memory is the main bottleneck. Large language models are incredibly memory hungry.
So 16 gigs of RAM isn't enough anymore.
Not even close. 32 gigabytes is the bare minimum now. 64 is honestly better. If you run out of RAM, the AI crawls.
And heat and noise are factors too.
Yes, small boxes throttle performance under sustained loads, like video rendering.
And gaming. We mentioned before, but these are not gaming rigs.
Right. Integrated graphics are good, but they aren't replacing a high-end gaming tower for AAA titles like Indiana Jones.
So to recap, we are really seeing a split in the market here.
Yes, between Copilot Plus ready workstations focused on office efficiency and local AI factories focused on heavy lifting.
The whole definition of a good computer has just fundamentally changed. It's no longer just about CPU speed.
It's about NPU efficiency and how much RAM you can fit in the box.
Which brings up a really provocative thought. As these agentic AI PCs become capable of running background tasks 24/7 without cloud costs.
How does that change our relationship with software subscriptions?
Exactly. Why pay $20 a month if your box does it for free?
Right. And with AI super build software from companies like Asus allowing users to customize their own LLMs locally,
Are we entering the era of personal AI sovereignty?
where you own your intelligence stack entirely.
Yes,
It's a massive shift.
it really is. Something for everyone to consider looking at their own desk setups.
Absolutely.
We appreciate you listening. Follow the Tech Life Well podcast for future episodes and updates.